This next section is one of the key modules of this content, and it's around using Google Compute Engine, or GCE, virtual machines. And the key reason here is this is how you're running your analysis at scale, leveraging the public cloud. Now, I really recommend you read all this information, but because this is so complex and I want to keep it short, I'm actually going to go right over to the console. I've actually started an instance on Linux, and the quickest way to get going with it is to just click SSH, and this will connect using an SSH client that Google makes available for you. And really, this is one of the reasons I think that the GCP cloud is great for genomics as well as other use cases, because it's super fast to get up and going. Other vendors, you'd have to do quite a lot more. I can't even get done describing it before it's ready. So now I can just type a Linux command and I'm connected and I can work with my virtual machine. So speed is an aspect of virtualized compute that is really powerful. I'm going to just close this window. Another aspect is a really cheap service cost. And then another aspect is flexibility. So you can see if I click the drop down here, I can work with this in other clients. For example, I could work with this in the embedded terminal using gcloud. And so if I click run in Cloud Shell, it's going to take this command and allow me to work in an embedded terminal. Now, this is pretty similar to an SSH window. The difference is this might be preferred when you're trying to capture scripts. And I've run this once before. The first time it has to do a metadata transfer, which takes maybe another few seconds. But again, it's just super fast. So working with the machine is very easy. There's no keys to transfer, there's no client to set up, which can get you up and going. Also, you can reuse configurations. Notice you can import virtual machines that you've created that have binaries or scripts on them. So rather than starting from a Google created instance, you can quickly get up and running at scale because you can set the amount of CPU, RAM, disk size, so on and so forth. So when you create an instance, you have a number of aspects that you want to look at. So the first aspect is where do you want to create it? It's really important that you create it in an area that is appropriate for your geography, where you are. Notice the pricing over here is very clear, easy to understand. There are 3 pricing models for virtual machines in Google. One is on demand, that's this price here. The second is if you want to have what's called a preemptible instance. This is for workloads that can be interrupted, and that is a switch in the advanced section here. And that is under the availability policy. It's really common in genomics when you have these very huge exploratory analyses where you turn that on. Do know, though, that the machines that you're running your compute job on could be shut off. So it's not for every type of workload, of course. But this can be really, really a lot cheaper than the on-demand. The other thing that I really like with Google VMs is that this service has automatic sustained use discounting. So if you turn on a VM and you need to leave it on for an entire month, for example, you'll get an automatic discount. You won't have to do anything, which is really compelling. So when you're setting this up, after you look at the region and zone, then you want to look at the machine family, and you can look at the machine types here. And you can see that there are different types for different workloads. Pre-configured standard, high memory, again, really common in genomics where you have maybe Spark or some sort of memory-intensive library. High CPU, mega memory, ultra memory, and this is constantly being upgraded. In addition to this, you can then add hardware for certain types of libraries. GPUs are common, so GPUs will work with some of the machine learning libraries like TensorFlow and really speed up those workloads. Now, of course, it's a cost versus time equation. The more you pay, the more power you get, and the faster your complex jobs run. So if you have less budget in your research budget, then you might choose not to have GPUs, for example, if you had TensorFlow, and you would just take longer to run your queries. Then the CPU, you can pick the type of CPU. You can deploy Docker containers by just switching this on. We'll see more about this in a subsequent movie. The default OS is Debian Linux, but you have some other images that you can pick from provided by Google. You have the different flavors of Linux, as well as you have Windows, if you would have some collaborators who are working with Windows, and you have some other specialty images, deep learning in particular. We'll look at that in a subsequent movie. Also, there's application images, mostly on SQL Server. And then here's where if you built custom images and made them available as files in Google Cloud Storage buckets, you would then create an instance, a VM instance from your image. Or alternatively, if you want to have a running image, turn it off so you can reduce costs because you get billed by the time increment when it's running. You can make a snapshot of the file and then you can run from a snapshot. So you have really just infinite flexibility here in terms of reducing costs. So when you're looking at VMs, you really want to think of them in terms of ephemeral compute. And what I mean by that is rather than just making a VM and leaving it on, you really want to think in terms of, unless there's a compelling reason that you want to leave it on, running your particular workload and then snapshotting or creating an image from your VM and then getting rid of the VM, just saving the file and then rehydrating it by creating a new VM. That's a pattern around VM usage. Now, if you're running raw VMs yourself, you're going to be doing all this. As we're working through this section of the materials, you'll see that there are a number of bioinformatics libraries that take advantage of these capabilities. And so they will, for example, use preemptible VMs. They will take snapshots and then rehydrate or restart VMs in order to reduce costs for you. So one of the key aspects of working effectively with GCP for scaled bioinformatic research is to figure out, are you in the experimenting stage and you just want to spin up your own VMs and configure them, or are you in a more complex stage where your workloads are bigger and you want more of this to be managed for you? Also, what's your budget? This is an area along with storage. So raw compute or VMs and storage are usually the key areas that you get charged. So these are the services that people use the most in research. So you really do want to understand the pricing and understand that time versus money continuum. Now going back to the information page, so I made a couple of maps through this landscape because it's got a lot of choices. And I mentioned this in the beginning of the course, but I'll say it again. You can see on the GCP spectrum, which is the blue services here, you could, of course, just completely not use VMs. You could use BigQuery. That's why I made the section on BigQuery, which is SQL query on files before this movie. However, I find that most researchers are using VMs. So once you use VMs, are you going to use raw VMs, or are you going to use any of these other libraries that sit on top? That will be in the rest of the section. When you're looking at them, you want to size your VMs correctly. You want to price them correctly. You want to look at the service costs. And then you want to figure out what type of client you want to use. And this is also from a security standpoint. So I showed you a couple of the integrated clients. Of course, you could also set up a client on your local machine. And then the last part of this is that you have a number of tools that can help you to validate that you've sized the VM correctly. So built into the console, you have quick viewers for the usage of CPU, the network I/O, the memory usage, so you can figure out if you need to get larger machines or more machines. Also, you're probably going to want to use some of the logging tools that we'll cover later in this course. But you do want to size correctly. And then last but not least, you want to secure correctly. So if you are going to be working with raw VMs in your research, you probably want to read this security best practices.